All right, so now we're on 2005, question 2, and we see that we've got another kind of this mass that's connected this time by 2 strings, and we see it's at equilibrium. We don't need to worry about this drawing right here or this length right here, so you don't really need that for what we're about to do. So it tells us the mass, tells us the angle, length, which we don't need, and the first thing it wants us to do is draw a free body diagram. And so we see that we have first got this tension going to the right, and we've got another tension going up like that. And so let's just call this T1, and let's call this T2. We've got our mg going down. So that's all that we are going to draw on this. We are not going to touch this anymore. If we need to draw another free body diagram, we just have to redraw it. So part B says calculate the tension in the horizontal strength. Horizontal means in the X and the Y, just in the X direction. So across, horizontal strength. So that's going to be our T2. So T2 equals question mark. So we don't really, have a lot of room right here. So let's just work over on this piece of paper. So let me redraw this free body diagram. So we've got our T2, we've got our T1, and we've got our mg. And so we see that our T1 is kind of weird because it's both in the X and the Y direction again. So again, we've got another triangle. So what is this theta right here? They don't give us that theta, but we can see that they actually do. So we see that the lines that we just drew were like this. And so we see that this angle must equal that angle. So that means that this theta right here is going to equal that 30. So we're trying to find this T2, and we see that T2 is in the X. So we're going to say the sum of the forces in the X, which we know is 0 because it's not accelerating, is going to be T2, and then we've got this T1 in the X direction right there, and that's going to be opposite of that angle. So, but let's just say minus T1 in the X. And so because it's opposite, we're going to say so we're looking for this T1 in the X, and it's opposite, so we're going to say sine theta is going to equal opposite, which is this T1 in the X, all over hypotenuse, which is just T1, multiply both sides by T1. And so we end up with T1x equaling T1 sine theta. So you end up with 0 equals T2 minus T1 sine theta. You can add your T1 sine theta to both sides. So we end up with T2 equaling T1 sine theta. But we have got 2 unknowns here. They didn't give us our tension 1, and we're looking for the tension 2, so we're going to have to set up another equation. So let's look at the sum of the forces in the y direction, which again equals 0. And then, so we have to look at this tension in the y, so T1y. All right, so we've got T1y minus, because it's going in the opposite direction of this mg. All right, now we have to find this T1y in terms of T1, and so we said it's adjacent, and so we see that we've got this, instead of sine, we've got cosine theta equals this T1y all over T1, multiply both sides by T1, and so we end up with T1y equaling T1 cosine theta. So we get 0 equals this T1 cosine theta minus mg. We can add our mg to both sides. So we end up with mg equaling T1 cosine theta. So now we've got 2 equations right here. We've got this first equation and the second equation. And this first one has got our T2. So we're going to have to use the second one to solve for our T1. So let's divide both sides by cosine theta. So we get our T1 equals mg all over cosine theta. Now we can plug all of this in for our T1. And so we get T2 equals mg divided by cosine theta times our sine theta. And we know that sine over cosine gives us tangent, so this is going to actually be tangent theta. So we end up with T2 equaling mg tan theta. Plugging everything in, so we're going to say we know that our m is this 1.8, g is 10, tangent of 30, so we end up with the T2 equaling 10.4 newtons. Now, if you don't really like substituting, again, there's an easier way, just like there was the last time. We, remember, start out with these two equations. So, but if you get it this way and don't want to do any further, just go ahead and stop this movie and just go on with a happy life. So let's look at a maybe easier way, those of you who really enjoy algebra and just want to, maybe do this problem a little bit quicker on your test. If you have this problem on your test, which you may or may not, I don't know yet. Or do I know? I don't know. Okay, so anyway, so we got T2 equals T1 sine theta, and then, well, we've got the other equation of this mg equals T1 cosine theta. And so look, now because we have one thing on this side and one thing on this side, we can just divide this out. And so by dividing out, we see that these T1s go away, and we end up with T2 all over mg equals sine over cosine, again, is tangent theta. Multiply both sides by mg to get T2 by itself. So we end up with T2 equals mg tangent theta. Plug everything in, and you should get the same thing. You should get the 10.4 newtons.